Alpha corrections. Question A. I'm going to break this down into question A, question B, question C. Consider an economy described by the following equations. Y, or national income, or national output, or GDP, is equal to C plus I plus G plus NX, NX being net exports. That's called the income identity. The next equation, C, this is the total consumption equation, is equal to 300. What is 300? 300 is autonomous consumption plus 0.8. What is 0.8? 0.8 is the marginal propensity to consume out of disposable income. And basically what that means is that, let's say, a household gets an extra dollar in disposable income. How much out of that dollar will the household consume? In our case, it'll consume 80 cents or 80% of the dollar, and it will save the rest. So if MPC is equal to 0.8, then NPS, the marginal propensity to save, out of disposable income will be equal to 0.2. So what you have here is the total consumption function. So the total consumption function is equal to autonomous consumption plus MPC times YD, which is the non-autonomous part of consumption, that part of consumption which is dependent on the fluctuations of gross domestic product. Next, what we have is physical investments. And here, physical investments are autonomous of the fluctuations of GDP. Next, we have autonomous G. Autonomous, again, not dependent on the fluctuations of gross domestic product. And we have net exports of 100, which implies that the economy is undergoing a trade surplus. In other words, exports greater than imports. And for the purposes of this model, we have to assume that NX is autonomous. Again, autonomous of, not dependent on the fluctuations of the business cycle. And the last entry is a personal income tax rate of 20% or 0.2. And one more thing, AE, what is AE? With a doohickey on top, that represents autonomous aggregate expenditures. AE is aggregate expenditures or total spending. What is total spending? Well, total spending is made up of consumption plus investments plus government spending plus exports minus imports, and autonomous, again with the doohickey on top, autonomous aggregate expenditures or autonomous total spending means spending aggregate expenditures which are not dependent on the fluctuations of the business cycle. So autonomous aggregate expenditures are autonomous C plus autonomous I plus autonomous G plus autonomous NX in this case. Calculate Y. We start off by putting together the model equation. So what is the model equation? It's made up of a numerator and a denominator. In the numerator, we have autonomous C plus autonomous I plus autonomous G plus autonomous net exports. And in the denominator, we have 1 minus MPC plus MPC times T. Again, this is the model equation. By model, we mean the goods and services market, the goods and services model equation. Or you remember the longer term, the Keynesian equilibrium income determination model, goods and services model for short. Okay, so autonomous consumption, there it is, 300 plus autonomous investments, here it is, another 300 plus autonomous government spending, there it is, 100 plus autonomous net exports, there it is, divided by 1 minus, what's MPC? There it is. It's 0.8. That's like that. Plus MPC, that's 0.8 times T, the personal income tax rate, which is 0.2. So, what do we get? 300 plus 300 plus 100 plus 100 is equal to 800. We divide by 0.36 and we get a GDP level of 2,222.22. I insist that you go to decimal points. Next step, calculate YD. So what's the equation for YD? Y minus TY. We've already calculated Y, 2,222.22, minus, what's T? That's 0.2, multiplied by 2,222.22. And what do we get? We get a disposable income level of 1,777.78. And once again, I insist that you go to decimal points. Calculate C. By C we mean total consumption. So here, total consumption is equal to autonomous consumption plus MPC times YD. We have autonomous consumption, that's 300. We have MPC, there it is again, 0.8. And we already calculated disposable income, 1,777.78. So total consumption is 1,722.22. All right. Now, next level of analysis. We've already calculated disposable income, and now we calculated consumption. The difference between disposable income and total consumption, I want to be more precise, total consumption will give us SP. Capital S, little p. So what is SP? SP refers to private savings. Private savings. The savings of the consumers, and only the consumers. Once again, SP refers to private savings, the savings of the households, of the consumers. So, we have previously calculated disposable income. We now have total consumption, and the difference will give us how much consumers save. Let's try something. What if, question mark, right? So what if disposable income is equal to total consumption? Well, we don't have the numbers, or we do, but I'm just talking conceptually. If YD is equal to consumption, then savings, SP, private savings, are going to be equal to 0. If, on the other hand, disposable income is greater than consumption, then we are going to have positive private savings. All right? Where will these savings go? Well, our model is going to assume that households are going to take this money and put it into this financial pool being made up of all sorts of financial institutions, which includes the very basic financial institutions, which are depository banks, depository institutions. And the third what if is the following. What if consumption is greater than disposable income? Well, if consumption is greater than disposable income, that obviously means that that private savings are going to be negative. And what does that mean? It means that as a group, we're looking at the net effect, that as a group, consumers, households, are going to be borrowing money from this financial pool that I just described. All right? So we will come back to this this calculation of SP with other problems in the very near future. Calculate BD or BS or BB. So in effect what we're doing is we're dealing with government finances. We're dealing with the government budget. All right, we already know that the equation to calculate all three possibilities is the following. TY, which represents tax revenues, minus government outlays. In our model, our only government outlay is autonomous government spending. So the personal income tax rate is 0.2. The GDP level is 2.22, and government spending, autonomous government spending, is 100. So we have a budget surplus in this case, because the number is positive, $344.44 billion. Again, 2 decimal points, I insist. And the question is, so we have a budget surplus, yeah? The question is, where does the money go? In other words, where does this $344.44 billion go? It goes to a financial pool, the domestic financial pool. It's an injection into the financial pool. If the calculations showed a BD, a budget deficit, that would mean that the government has government outlays which are higher than tax revenues. So in effect, what the government would be doing is withdrawing or borrowing money from this financial pool, which is made up of all sorts of financial markets. But I will have a lot more to say later on. And now the super fun part. That's where I get to draw, which I miss the most about not being in class. So, okay, let's see. Here on the y-axis, aggregate expenditures. The term aggregate means sum, total. So in effect, aggregate expenditures can also be called total spending. Total spending by whom? Consumers, firms, government, and foreigners. So what are aggregate expenditures? Aggregate expenditures are consumption plus investments plus government spending plus exports minus imports. Here we have 0, and here on the x-axis we have y, GDP, or national output or national income, which is consumption plus investments plus government spending plus exports minus imports. Nextly, we have this 45-degree help line. What is the slope of this 45-degree help line? That's right, the slope is 1. It's a straight line, and it cuts up the right angle into 2 equal parts. So again, the slope is equal to 1. Any point on this 45-degree help line represents the goods and services equilibrium, which means that any point along this 45-degree help line, aggregate expenditures are equal to national income. Now, what we do nextly is we take all of these numbers, these equations, and we put together this line, which we are calling a curve, aggregate expenditure curve. All right. Now, where does the curve start? It starts here. It starts at this point here, which we designate as autonomous aggregate expenditures. Autonomous aggregate expenditures. So what are autonomous aggregate expenditures? Autonomous C plus autonomous I plus autonomous G plus autonomous X, and then we subtract M. Or we could phrase it differently, plus NX autonomous. Okay, now in our model, in our problem, in our question, the value of autonomous aggregate expenditures is equal to 800, right? Okay, so this intersection of this aggregate expenditure curve and the 45-degree help line derives equilibrium. What exactly does it mean? It means the following. It means that total aggregate expenditures are equal to total production or output of the economy. So whatever is demanded by consumers, firms, the government, and foreigners, which represents total spending or aggregate expenditures, is equal to the output, the production, the supply side. Y being total supply. It means gross domestic product. And what are the values? Well, what is the value of aggregate expenditures? It's 2,222.22. That's how much is demanded and how much is supplied. Y is equal to 2,222.22. That's the meaning of equilibrium. Aggregate expenditures right here are equal to Y right here.